welcome back. We're going to be doing a topic on infinite limits, or there's basically infinity in the bounds, how that works. There's a whole limit process. Once you know how to do it, it's not too bad, but it can be pretty intimidating at first. I want to give you one where you can practice it in an intro way. So it looks something like this. You're going to have infinity in the bounds. I picked an example with both infinities just to make sure you're super prepared. And we'll use integral of 1 over 1 plus x squared. Now you might be asking, they get much harder than that. They do. I'm choosing a kind of simpler integral so you can kind of focus on solving the infinite integral as opposed to doing a whole other process, just to get used to it. Basically what we're going to be doing first is we're going to be separating this integral into two parts. So what it will be is we can just say this is the same thing as negative infinity to 0 of 1 over 1 plus x squared dx plus the integral from 0 to infinity of 1 over 1 plus x squared dx. It did the same thing, right? It's the same thing. I'm just separating the two so we can focus on each infinite problem bounds at the time. Because infinite bounds we have to handle a special way. Now I'm going to do two other things to help us solve. Whenever there's infinite integrals, they're going to need you to use limits. It might seem kind of arbitrary, but it's the easiest way to see what the number, if it all converges to something, what that would be. Okay, so what we're trying to find out in this problem is we're trying to see, does this integral converge? In other words, does it equal some number at the end if we go off to infinity? And if it doesn't, then it diverges. If it goes to infinity either way, then it diverges. And you'll see what I mean. So what we're going to be doing is we're going to set up that problem. So we're going to take a limit, the limit as b. Usually it's b. You can choose any letter you love, but b is pretty common. Just don't use x unless you want to be a rebel. Of limit as b goes to a negative infinity. So basically we're going to replace the infinity on each one. So one of the limits would be negative infinity is this b, so b to 0, 1 over 1 plus x squared, and we're just going to add another limit, right? So we can do that. We can add infinite limits together. That's fine. It doesn't really matter. And this b is going to represent the infinity. So 1b represents negative infinity, 1 represents positive infinity. I know the b kind of seems ridiculous, but it's just to kind of help with clarity, and technically that's the math correct thing to do. So what we do now is we solve the integral. So we've separated it, we've created the limit, we've gotten rid of the infinity value because that's hard to, you can't use those integrals, it's a big no-no. And now we just solve this integral. So this integral is a pretty standard integral. It's the definition integral for arctangent. If you don't know about those special ones you have to memorize, there's tons of videos on it, but just know 1 over 1 plus x squared is the integral for arctangent. So we would say this is the limit as b approaches infinity of the arctangent. So this is just going to be the arctangent of x from b to 0 plus the limit as b goes to infinity. Again, this is negative infinity, I keep forgetting that, of the, apparently, my brain's elsewhere, of arctangent of x. So again, they equal the same thing, right? We're just dealing with the two separate bounds. So one's b to 0, this one is 0 to b. Okay, so what do we do now that we have the actual integral solved, but we need to plug in the values, right? So this is a weird integral with the limits in infinity and b, but this is just the same integral. This is a definite integral. So how do we solve definite integrals? Well, we need to solve each definite integral separately, right? So what we would do is we would kind of arrange that, right? So this arctangent, we have the first number, or I should say, sorry, the top number minus the bottom number. So the arctangent of, right, the first one would be 0 minus the arctangent of b, right? And then we're going to add another limit. So again, this whole thing was this part, and we're going to do the same thing for this second part. So it's going to be the limit as this other b, this is negative infinity, by the way, of infinity of arctangent of the top number, so b minus the arctangent of 0. So very similar, right? We're just kind of flipping it because we're dealing with two sides of infinity with our integral. So this is kind of where students start to get stuck a little bit because you have to remember trig for this to make sense. So an arctangent, right, is just kind of the answers of a tangent function. So to figure out how infinity works, if we basically, we're not writing infinity, right, or negative infinity, but we're assuming that this is like negative infinity, this is infinity. So how do we figure out if those answers are a number or if it's not? So that way, if we don't know the answers to this, how can we solve the expression, right? So what we would do is we would kind of need to refresh our trig a little bit. So let's just say, if you recall, a tangent function kind of looks like this, a bit like a cubic function. It's going to have an asymptote on either side. It's going to meet at the origin at 0, and at 0, 0. And at this part, right, the first asymptote is always going to be at negative pi over 2. And another one will be at pi over 2. Okay, so what we do is we take this information and we can kind of tell the answer. So if arctangent of 0, that's kind of a value you might just know from trig. But if you don't, that's okay. That's just saying if we have an answer of 0, what does the tangent value it? Well, we know that tangent at 0 is 0. So arctan of 0, right, is just 0. So that's good. So we have the limit as b approaches infinity. Again, I'm not solving the limit really. I'm just finding these values. That's all you do. You're solving the integral equation inside so that you can figure out what the limit is of this original expression. So arctan of 0 is 0. Okay, minus, what's the arctangent of negative infinity? Well, let's reference our chart, right? So we have these arrows here, right, which represent infinity. So this would go on forever. So over here, this is negative infinity. This is infinity, okay? So if we go down to negative infinity, which value are we approaching, but won't ever come across, but we are approaching that, and we will meet it as it goes to negative infinity? Well, it's negative pi over 2, right? So at negative infinity, remember, because we have a negative infinity here, that's what b is in this part. That's negative pi over 2. And then we have the limit as b approaches infinity of this other part, right? So now we have the arctangent of b, which is infinity. So it's pretty similar, right? If we go off to infinity, if our answer is infinity, our arctangent, what value of tangent is that approaching? Oh, well, it's pi over 2, right? It's approaching pi over 2 if our answer is infinity. Okay, fair enough, right? So that's pi over 2 minus, and we already know the arctangent of 0 is 0 from basic trig values. So what we have is 0 minus a negative pi over 2, right? So that would be the same thing as just kind of a positive pi over 2. And if we notice, right, we've actually solved the equation, but there is no, we don't have to, once we put infinity, the infinity goes away, right? Because we plugged in, I know this is a little bit confusing if you've never done this before, but if we, just like a normal limit, if we plug in the value, then we're solving it, right? So we set up the whole equation, then we plugged in infinity to our b, so we plugged in, right, technically we figured out what negative infinity would be here, what would infinity be right here. And then we found those values, they actually are values, and we just plug those in, and now we can solve. So technically, we don't have to write the limit anymore, we've solved it. I was just trying to get you to see that this limit and this limit are from the same, okay? So if we have 0 plus a pi over 2, and we just added this the whole time, right? So pi over 2, so plus a pi over 2 minus 0, because we're just adding the two limits together. Since we solved the limit, we got rid of all the b's, we solved that infinite limit part. Now we just have to figure out what these values are. Well, pi over 2 plus pi over 2, that's just 2 pi over 2, right? Or that's just pi. So the answer to this whole thing is pi. Now if you get a number, right, so if it's not infinity, when we do the whole limit out, then we know this actually converges. So we'd say converges. And that would be our answer. We would say converges, to pi as a number. So this is how you would do infinite integrals. our limits at infinity dealing when there are integrals in the problem. Basically, remember, we're just going to get our answer with one or two infinities in it. We're going to separate if we need to. Then we're going to use our limit with b. We're going to solve our integral as if there were no weird limits floating around. And then once we solve our integral, then we have our bounds. We plug in our bounds. We have to abstractly figure out what infinity would mean. Does it just go to infinity, which it sometimes does, or does it equal a number? In this case, it equaled a number. We add those numbers together. We get a final number. We figured out the total area, basically, of this convergence. I do this problem because it's actually pretty interesting. I think it's one of the more interesting ones you can see. You can see the finite area of an infinite integral, which is pretty insane, that the whole area of an infinite amount of area of this graph, basically, would be equal to just pi. So this is how pretty much a hard version of this problem would be. Like I said, there can be other techniques that they use on top of it, like partial fractions. But if you could do something like this, where there's two different infinities, then you can do all the others. So hope this intro video for infinite integrals worked. And yeah. Thanks for watching. Bye.